Next chapter is chapter 5, Arithmetic Progressions. In this chapter, the formulas involved are nth term an equals to a plus n minus 1 into d, and for the sum of n terms, Sn equals to n by 2 into 2a plus n minus 1 into d. For the sum of n terms, we have one more formula, n by 2 into a plus l. In an arithmetic progression, if we have the first term and the last term, the sum of n terms will be n by 2 into a plus l. So these two formulas are important. And there's one more formula. For finding the nth term, an equals to sum of n terms minus sum of n minus 1 terms. We even use this formula for finding the nth term. So let us start our session now. The first question is, the nth term of an AP is given by an equals to 3 plus 4n. The common difference is, so we need to find the common difference here. If I substitute the value of n equals to 1, a1 equals to 3 plus 4 into 1, which is 7. a2 equals to 3 plus 4 into 2, which gives me 11. So common difference d equals to a2 minus a1. That equals to 11 minus 7, which is 4. So option C is the answer. Second question. If P, Q, R and S are in AP, then R minus Q equals to. If these three are in AP, I can say that Q minus P, which is the common difference D, Q minus P equals to R minus Q equals to S minus R. So I can get these three terms here. So Q minus P equals to R minus Q equals to S minus R. R minus Q will be equals to S minus R. Option C. Next question. If the sum of three numbers in an AP is 9, given sum of three numbers equals to 9, and the product is 24, then the numbers are. So we'll try to verify instead of solving the problem. In the first option, sum of three numbers equals to 2 plus 4 is 6 plus 6 is 12. The sum is not 9. In the second option, it's 5 plus 4 is 9. So second and fourth are satisfying the condition. And the product is 24. The product is 24 only in the fourth option. So option D is the answer. Fourth question. The n minus 1th term of an AP is given by. So we want n minus 1th term. We know that nth term formula is a plus n minus 1 into d. That equals to here a equals to 7 plus n minus 1 into d equals to 5. If I want n minus 1th term, in the place of n, just substitute n minus 1. That is 7 plus n minus 1 minus 1. In the place of n here, I just substituted n minus 1, and this minus 1 is from here. That equals to 7 plus n minus 2 into 5, which is 7 plus 5n minus 10, which gives us 5n minus 3. So option D is the answer. Next question. The nth term of an AP 5, 2, and so on is given by. So in our arithmetic progression, the first term a equals to 5, the second term is 2, and so on. Here the common difference d equals to 2 minus 5 is minus 3. So d equals to minus 3. Nth term will be a plus n minus 1 into d. So here a equals to 5 plus n minus 1 into d is minus 3. That equals to 5 plus n into minus 3 is minus 3n. Minus 1 into minus 3 is plus 3. That equals to 8 minus 3n. So option C is the answer. Next, moving on, 6th question. The 10th term from the end of the AP is given as. We need to find the 10th term, but from the end. So what we do is here, we'll just try to flip the arithmetic progression. We'll write in the reverse order. The first term is minus 1000. And the next will be, here the first term is minus 5. And second term is minus 10. Common difference d will be equals to minus 10 minus of minus 5, which is plus 5. So common difference equals to minus 5. Whenever we reverse the arithmetic progression, the common difference will change its sign. The reverse AP, in reverse AP, the first term is minus 1000 and the common difference will be plus 5. So this is minus 995 and minus 990 and so on. So A equals to minus 1000 and D equals to minus 5. Sorry, D equals to plus 5, the reverse AP. So the 10th term, A10 equals to A plus 10 minus 1 into D, so 9D. A is minus 1000 plus D is 5, so 9 into 5 is 45. So minus 1000 plus 45 equals to minus 955. So A10 equals to minus 155. So option A. Next question is, find the sum of 12 terms of an AP whose nth term is given by an equals to 3n plus 4. We need to find the sum of 12 terms whose nth term is given by this. So the first term A1 equals to 3 into 1 plus 4, which is 7, and the second term equals to 3 into 2 is 6 plus 4 is 10, and so on. So for this the formula is n by 2 into 2a plus n minus 1 into d. Since I want the sum of 12 terms, this is 12 by 2 into 2 into a. So a1 is the first term right here. So 2 into 7 is 14 plus n is 12 already, so 12 minus 1 is 11. Common difference d equals to a2 minus a1, which gives us that equals to 10 minus 7, 3. So 11 into 3. That equals to 6 into 14 plus 33. That equals to 6 into 14 plus 33 is 47. So 47 into 6. It is 262. Option A. Next is 8th question. The sum of all two-digit odd numbers is, sum of all two-digit odd numbers. So odd numbers starts from, I want two-digit odd numbers. So generally the two-digit number starts from 10 and go on up to 99. And if you go to 100, 100 is a three-digit number. So this is not the one. So 100 is not a two-digit number. So from 10 to 99, the odd numbers are 11, 13, 15 and so on up to 99. The sum of these digits equals to, I told you the formula, sum of n terms equals to n by 2 into a plus l if I have the first and the last terms. So I have the first and the last term here. Coming to the value of n, there are total of 100 two-digit numbers, out of which 45 are the natural numbers, 45 are the even numbers and 45 are the odd numbers. So n value is 45 here. 45 by 2 into, first term is 11 and the last term is 99. That equals to 45 into 99 plus 11 is 110. 110 by 2, this is 55. So 55 into 45. This is 5 into 5 is 25. This is 25 plus 2 is 27. And this is 22 carry here. And this is 22. So it is 2475, which is option B. Next, the sum of first n odd natural numbers is. So you want the sum of first n odd natural numbers. So the odd natural numbers start from 1, 3, 5 and so on up to 2n plus 1. Or else I'll write it as 2n minus 1. 2n minus 1. So if n equals to 1, then it is 1. The a1 will be 1. If n equals to 2, it is 3. This is my nth term for natural numbers. The sum of these will be Sn equals to, I want sum of n natural numbers, n by 2 into, I have the first term which is 1 plus the last term is anyway 2n minus 1. So plus 1 minus 1 gets cancelled, which equals to n by 2 into 2n. 2 gets cancelled here and equals to n squared. So n squared is the sum of first odd natural numbers, which is option D. Next, 10th question. If p plus qth term of an AP is m and p minus qth term is n, then pth term is. So we have p plus qth term, AP plus q equals to, the general formula is that a plus n minus 1. Here n is p plus q, so p plus q minus 1 into d is the common difference. And this term is given as m, so equate this equals to m. And similarly, a p minus qth term equals to a plus p minus q minus 1 into d. This is given as n. We need to find the pth term, that is ap, a suffix p. On adding these two, plus q and minus q gets eliminated and I am getting p variable in this. So if I add this is 2a plus p is 2p and q minus q gets cancelled and minus 1 gets minus 2 here, of d equals to m plus n. taking out 2 common in this expression, 2 of a plus p minus 1 into d equals to m plus n. So a plus p minus 1 into d equals to m plus n by 2. If I write the general term for AP, it is a plus p minus 1 into d, which is the required solution. So this is my AP term, that equals to m plus n by 2. So option D. Next question is 11th one. If a comma b comma c are in AP, then a minus b by b minus c. If a, b, c are in AP, common difference d equals to b minus a or equals to c minus b. Here I want a minus b by b minus c. Take out minus from the numerator, which is, if I take out minus, it becomes b minus a. If I take out minus in the denominator, it becomes minus of c minus b. So which is common difference d in both the cases. So these two are one and same, both gets cancelled, it gives you 1. So option A is the answer. Next, 12th question. The number of multiples lie between n and n square which are divisible by n is. Let us take an example to understand this question. If I take a number like 5, the 5 square is 25. So in between 5 and 25, I have 5, 10, 15, 20 and 25. The number of multiples lie between n and n square which are divisible by n. In between 5 and 25, there are 3 multiples. These 3 multiples are divided by my number n. So these are 3 now. So for 5, I got 3, which is 5 minus 2. If I take n, I'll be getting n minus 2. So that's a simple analogy. So I have n minus 2 terms. Next is, if a comma b comma c comma d comma e are in AP, then the value of a minus 4b plus 6c minus 4d plus e is given as. Let us write this as a equals to a and b equals to second term, which is a plus d. If d is my common difference, b equals to a plus d, and c equals to a plus 2d, d equals to a plus 3d, and e equals to a plus 4d. I want a minus 4b, so a minus 4 into b. Here b is a plus d plus 6 into c, right? So 6 into c is a plus 2d minus 4 into d. D is a plus 3d plus e is a plus 4d. So which is equals to a minus 4a minus 4d plus 6 into a plus 12d minus 4a minus 12d plus a plus 4d. So adding all these terms, a minus 4 is minus 3a, minus 3a plus 6a is plus 3a, plus 3a minus 4a is minus a, and minus a plus a is 0. So all the 8 terms got 0. Now look at the d terms. Minus 4d plus 12d is plus 8d, plus 8d minus 12d is minus 4d, and minus 4d plus 4d is 0. So I got 0 plus 0. So it's just 0. The answer is A now. 14th question. The next term of the sequence is, so here he gave the AP. We need to find the next term. The first term is given as 1 by 1 plus root x. If you rationalize this, I will get into 1 minus root x by 1 minus root x, which gives us 1 minus root x by, this is a plus b into a minus b. So 1 square minus root x whole square is 1 minus x. The first term is this, and second term is 1 by 1 minus x. If I want to find a common difference, it will be second term, which is second term is 1 by 1 minus x minus first term is 1 minus root x by 1 minus x. This is the first term, right? So that equals to 1 minus minus 1. So 1 minus 1 minus into minus plus root x by 1 minus x. So common difference equals to root x by 1 minus x. For the third term, you add this common difference. The third term is 1 by 1 minus root x. So rationalize this to get the 1 minus x as the denominator. 1 plus root x by 1 plus root x. The third term equals to 1 plus root x by 1 minus x. And add the common difference d plus root x by 1 minus x. That gives us 1 plus 2 root x by 1 minus x. So the option is D, 1 plus 2 root x by 1 minus x. Next, 15th question. Nth term of the sequence is given as, so a comma a plus d. It's a direct formula, which is a plus n minus 1 into d. 16th one. The 10th term from the end of the AP is given as, so we did in the previous problem. 10th term from the end. So reverse the AP first. My first term will be 254. For the given AP, common difference d equals to 9 minus 4, which is 5. In my reverse AP, it becomes d equals to minus 5. So it will be 254, next is 249, next is 244, and it keeps going. I need to find the 10th term. So A10 equals to, my first term is 254 plus n minus 1 is 9 and d is minus 5. So 254 minus 45. 254 minus 45 equals to 209. Option A. 17th question. If 2x comma x plus 10 comma 3x plus 2 are in AP, then x is equal to. We know that if 3 terms are in AP, the middle term will be equal to the average of other 2 terms. So it's like the arithmetic mean. Or I can say that 2b equals to a plus c. So 2 times of b here is 2 into x plus 10 equals to a plus c. A is 2x and c is 3x plus 2. This is 2x plus 20, that equals to 5x plus 2. So bring this 2x to the right hand side and 2 to the left hand side. 18 equals to 3x. That implies x equals to 6. The value of x is 6. The sum of all odd integers between 2 and 100 divisible by 3 is. So we need to find the odd integers between 2 and 100 and they are divisible by 3. So the multiples of 3 are 3, 6, and so on up to the number which is divisible by 3 and less than 100 is 99. But in this, I only want the sum of all odd integers, which includes 3, and the next odd integer is 9, and the next is 15, and the next is 21, and so on till 99. In this arithmetic progression, take out 3 common. If I take out 3 common, I have 1, 3, 5, 7, and so on till 33. I want sum of all this. So 3 into sum of n terms formula is 33 by 2, n by 2 into a is 1 plus n minus 1 is 32 into 2 is the common difference. That equals to 3 into 33 is 99 by 2 into 32 into 2 is, so 32 into 2 is 64. 64 plus 1 is 65. I'm sorry, I'm getting some fractions. Sum of all the odd integers between 2 and 100 is 3, 6, and so on up to 99. I want only the odd integers. So it's 3, 9, 15, 21, so on 99. From 1 to 33, 33 is my lowest term, which is an equals to a is 1 plus n minus 1 into 2 equals to 33. So n minus 1 into 2 equals to 32, n minus 1 equals to 16, n equals to 17. So I'm sorry, the n value is 17 here. So 3 into n by 2, so 17 by 2 into a is 2 into a, so 2 plus n minus 1 is 17 minus 1 is 16 into common difference is 2. That is 3 into 17 by 2. 3 into 17 is 51. 51 by 2 into 16 into 2 is 32. 32 plus 2 is 34. So this is 217 times. 51 into 17. This is 7 1 times 7. 7 5 times 35. This is 50. So it is 867. So option B. Next is 19th question. If the numbers a, b, c, d, e are in AP, so we did this problem already, which is equals to 0 already. Next is if seventh term if 7 times the 7th term of an AP is equal to the 11 times its 11th term, then 18th term will be. He gave that 7 times the 7th term, A7, equals to the 11 times the 11th term. Then A18 equals to what? That's a question. So here it is 7 into A plus n minus 1 is 6D equals to 11 into A plus n minus 1 is 10 into D. So it is 7 into A plus 7 into 6 is 42D equals to 11A plus 110D. This equals to 7A. 11A minus 7A is 4A plus 110 minus 42. So 110 minus 40 equals to 70. 70 minus 2 is 68D equals to 0. I want the 18th term. The 18th term will be equals to A plus 17D. I need to find the value of A plus 17D. Here if I take 4 common, A plus 4 1 times is 4, 4 7 times is 28. I got A plus 17D equals to 0, which is the required one. So my 18th term is becoming 0. Next is, if P comma Q comma R are in AP, then P cube plus R cube minus 8Q cube is equal to. If these three are in AP, I can write that 2Q equals to P plus R. I can say that P plus R minus 2Q equals to 0. Whenever we have A plus B plus C equals to 0, we have a formula for this which says that A cube plus B cube plus C cube equals to 3ABC. So it is a formula, just try to remember this. You can skip this question if you want because you don't have this concept as of now. So here my A is P, my B is R and C equals to minus 2Q. If I rewrite this, P plus R plus, in the place of C I have minus 2Q. If this equals to 0, then according to the formula, A cube is P cube and B cube is R cube and C cube is minus 2Q whole cube, which is minus 8Q cube. That gives us 3 into A is P and B is R and C is minus 2Q, which gives 3 into minus 2 is minus 6, minus 6 PQR. So minus 6 PQR is option B. We'll go to next question now. In an AP, if so this is A equals to 3.5. I need to find the A101 term. So this is A101 term. A101 term equals to, then A will be, so there's some printing mistake here. Yes, in an AP, if A equals to 3.5, D equals to 0, then A101 is equals to what? So this is the question. So D equals to 0. So when D equals to 0, our AP becomes, first term is 3.5 and the next term is plus 0, which is 3.5, 3.5. I'll be getting the same constant term, which is 3.5. So any term of the AP is 3.5. Even if it is A101, it will be 3.5 itself. Option B. 23rd question. The list of numbers minus 10, minus 6, minus 2 is, let us try to find the common difference. A2 minus A1 is minus 6, minus of minus 10 is plus 10, which is 4. A3 minus A2 is minus 2 plus 6 equals to 4. So it is an AP with the common difference as 4. An AP with difference 4. Next is 24th. Two APs have the same common difference. The first term of one of these is -1. Let us categorize AP1 and AP2. The first term of one of these is -1. In my AP1, my first term A equals to 1, and all of them have the same common difference. And in AP2, the first term is -8. The next term will be -1 plus D, and so on. Here it will be -8 plus D, and so on. Then the difference between their fourth terms is, here my fourth term equals to -1 plus 4 minus 1 is 3D. Here my fourth term equals to -8 plus 3D. I want the difference. So difference equals to -1 plus 3D minus of -8 plus 3D. So which gives us -1 plus 3D plus 8 minus 3D. Minus 3D plus 3D gets cancelled, that equals to 7. Option C. Next, in an AP, if D equals to -2, N equals to 5, AN equals to 0, the value of A is, given that AN equals to 0, that implies A plus N minus 1 into D. So A plus N minus 1 into D equals to 0. The value of A we need to find. A plus N value is given as 5. So 5 minus 1 is 4. D is given as -2. That equals to 0. A equals to 8. Option D. Next is 26th question. If the common difference of an AP is 3, then A20 minus A15 is. So given the common difference D equals to 3, we need to find A20 minus A15. The general formula of A20 is A plus 19D minus, for this, A plus 14D. So this is A plus 19D minus A minus 14D. Minus A plus A gets cancelled. 19 minus 14 is 5D. D is given as 3. So 5 into 3 is 15. The next term of the AP is, so whenever we have the roots, try to simplify these roots first. I have root 18. So root 18 equals to, you can write it as root of 3 into 9, so 2 into 9, which is 3 root 2. And the next term, root 50 equals to 2 into 25, that is 5 root 2. And the third term is 98. I can write it as 2 into 49, which is 7 root 2. So if you look at these three terms, the difference is 2 root 2. For the first term, if we add 2 root 2, it becomes 5 root 2. And if I add 2 root 2 for this, it becomes 7 root 2. So common difference equals to 2 root 2. This is the common difference. We need to find the next term. So add 2 root 2 for this. It becomes 9 root 2, which is 2 into. If I take this 9 inside the square root, it becomes 9 square, which is 81. So 81 into 2 is 162. Option C. The common difference of the AP is, I need to find the common difference here. So common difference equals to take A2 minus A1 here. That equals to 1 minus P by P minus 1 by P. That equals to 1 minus P minus 1 by P. 1 minus 1 gets cancelled. Minus P by P is minus 1. So this is the common difference. 29th question. If the nth term of an AP is 2n plus 1, then the sum of its first 3 terms is. This is the nth term. I want the sum of first 3 terms. A1 plus A2 plus A3. I have an equals to 2n plus 1. If n is 1, a1 equals to 2 into 1 plus 1 is 3. If n is 2, it is 2 into 2 plus 1 is 5. And if n equals to 3, this is 7. Sum of these 3 will be 15. 30th question. An AP consists of 31 terms. If its 16th term is m, the sum of all the terms of this AP is. So total we have n equals 31 terms. 16th term is nothing but a plus 15d, which is equals to m. I need to find the sum of all the terms of the AP. If you look at the options, it gave these options in terms of m, some constant into m value. So sum of n terms equals to 31 by 2 into a plus n minus 1 into d. That is, n minus 1 is 31 minus 1, which is 30 into d. So these are the sum of n terms. That equals to 31 by 2 into, if I take out 2 constant, 2 into a plus 15d. So 2 gets cancelled here, that equals to 31 into a plus 15d equals to the value of m. So it is 31m, option C. 31st question. The first term of an AP of consecutive integers is p square plus 1. The sum of 2p plus 1 terms of the AP is given as. The first term a1 equals to p square plus 1. The sum of 2p plus 1 terms of this AP will be. Since we have the consecutive integers, instead of solving this question with the variable p, we will assign a value for p. Let us say p equals to 3. If p equals to 3, then a1 will be equals to 3 square is 9 plus 1 is 10. So a1 equals to 10 and a2 will be equals to 11 because they are consecutive integers. So they'll be having the common difference of 1. a2 equals to 11 and a3 equals to 12. So this is our AP. If I substitute the value of p equals to 3 here, I want the sum of 2p plus 1, which is 2 into 3 plus 1. That is sum of 7 terms. Sum of 7 terms equals to 7 by 2 into a. So 2 into a is nothing but 2 into 10 is 20 plus n minus 1 into d. N minus 1 is 6 into d is 1. That gives us 7 into, this is 26 by 2, 13. 13 into 7 is, so 13 into 7 will be 91. Now you place the value of 3 in the options and check if it is 91. Option A 3 plus 1, 4 square is 16, no. And option B is 2 into p plus 1 is, so p equals to 3, so it is 7. 7 into p plus 1 is 4 square 16. 16 into 7, no. And p plus 1 whole cube. P plus 1 is 4 cube, which is 64. Option D is 3 cube plus, this is 4 cube. So 3 cube is 27 and 4 cube is 64. So it gives us 91. Option D. 32nd question. If the sum of first n terms of an AP is a into n plus b n square, where a comma b are constants, the common difference of AP will be so this is a sum of n terms. Sum of n terms equals to a into n plus b into n squared. I want common difference. Common difference will be equals to a2 minus a1. But in our question we don't have a2 and a1. It directly gave the expression for the sum of n terms. In the beginning of this class I told you the sum of n terms formula and also the an equals to sum of n terms minus sum of n minus 1 terms. So this gives us the nth term. If I want second term, a2 will be equals to sum of two terms minus sum of one term, that equals to. So place the value of 2 in the place of n. So s2 equals to 2 into a plus b into n square is 4b minus sum of one term is a plus b. This gives us 2 into a plus 4b minus a minus b, which is equals to 3b plus a. This is my second term and I want the third or the first term. I'll try to find the first term. First term a1 will be equals to sum of one term, that equals to first term. Whenever we have AP like 2, 4, sum of first term is equals to the first term itself. So S1 equals to A plus B. A plus B itself is the first term. So common difference D equals to A2 minus A1. A2 is 3B plus A minus A1 is minus A minus B. A minus A gets cancelled. 3B minus B is 2B. So 2B is the common difference. That is option D. 33rd question. If P minus 1, P plus 3, 3P minus 1 and AP, P is equals to. So 2B equals to A plus C. Here 2 into P plus 3 equals to A plus C equals to P minus 1 plus 3P minus 1. That implies 2P plus 6 equals to, this is 4P minus 2. So 2P equals to 8, P equals to 4. Thirty-fourth question. Write down the first 4 terms of the sequence whose general terms are. So you can write this general terms given the nth term. So T1 equals to 2 into 1 plus 3 is 5 and T2 equals to 2 into 2 plus 4, 2 into 2 plus 3 which is 7 and so on. You can write even for the second and third problems. 35th question. Find the 10th term of 10, 10.5, 11, 11.5 and so on. Here the common difference equals to 0.5. 10th term an equals to a plus n minus 1 into d. So a equals to 10 plus n minus 1 is 9 because I need to find the 10th term. N minus 1 equals to 9 and d is half. That equals to 10 plus 4.5 which is 14.5. 36th question. In an AP, if the common difference equals to minus 4 and the 7th term is 4, then find the first term. D equals to minus 4 and the 7th term is given as 4. That implies A plus 6 D equals to 4 and D is given as minus 4. So A equals to 4 minus 6 into minus 4 which is 4 plus 24, 28. Next one is 37th one. Write the nth term of an AP Given the arithmetic progression is 1 by m comma 1 plus m by n. In this arithmetic progression, common difference equals to second term is 1 plus m by m minus first term is 1 by m, which gives us 1 plus m minus 1 by m, that equals to 1. Write the nth term of the AP. So common difference equals to 1. So nth term an will be equals to a plus n minus 1 into d. First term equals to 1 by m plus n minus 1 is n minus 1 itself and d is 1. On taking the LCM, it is 1 plus n minus 1 into m by m, that equals to 1 plus mn minus m by m. So 1 plus mn minus m by m is the nth term. Next is 38th question. Which term of the AP is 0? My first term is 21 and the common difference equals to 18 minus 21, which is equals to minus 3, and I need to check which term is 0 now. So write the condition an equals to 0 and solve this. My first term equals to a plus n minus 1 into d equals to 0. That implies 21 plus n minus 1 into common difference equals to minus 3. Minus 3 equals to 0. This gives us 21 plus minus 3 into n is minus 3n. Minus 1 into minus 3 is plus 3 equals to 0. 21 plus 3 is 24. 24 equals to 3n. And n equals to 8. My 8th term will be equals to 0. So it's 8th term. Next is 39th question. For what value of p are 2p plus 1, 13 5p minus 3 consecutive terms of an AP? These three will be consecutive terms only if you have the same common difference. So common difference d equals to 13 minus 2p plus 1. I took a2 minus a1 here and take a3 minus a2 here, which is 5p minus 3 minus 13. So this is 13 minus 2p minus 1 is 12 minus 2p, that equals to 5p minus 16. This is 28 equals to 7p, p equals to 4. So p equals to 4. Next, what is the common difference of an AP in which a21 minus a7 equals to 84? a21 will be a plus 20d minus a7d will be a plus 6d equals to 84. Whenever we do subtraction, just be careful with these brackets. So it's minus of a plus 6d. A plus 20d minus a minus 6d equals to 84. Minus a plus a gets cancelled. 20d minus 6d equals to 14d. 14d equals to 84. So d will be equals to 84 by 14. So this is 2 7 times. It is 241 times. 242 times. So 7 6 times. So d equals to 6. The first term of an AP is p and its common difference is q. Find its 10th term. So a equals to p and d equals to q. So 10th term will be equals to a plus 9d. Nothing but p p plus 9q. So last question, which term of the AP is minus 1? Let us say my nth term equals to minus 1. That implies a plus n minus 1 into d. So a equals to 14 plus n minus 1 into d equals to 11 minus 14 is minus 3. This will be equals to minus 1. So 14 plus minus 3 into n is minus 3n, minus 3n plus 3. So 3 minus 3n equals to minus 1. Let me erase this space here. So this is 17 minus 3n equals to minus 1. 17 plus 1 is 18 equals to 3n. So n equals to 6. So 6th term equals to minus 1. So these are the questions from the arithmetic progressions chapter. We'll continue the problems in the next chapter.